In section 7.1, we're going to be focusing on the area between two curves. We found the area of a function made with the x-axis, and we've seen that it can be a positive area and a negative area. Now what we're going to do is we're going to introduce two functions. Say we give you a f of x here, and maybe we have a g of x that comes in down here. Notice we have the intersection of these two regions, and we can find the area of this region that's created by these two graphs if we know this value of intersection, or a value, and we know this value, which we'll call a b value. And the way we would do that would be to find the area of the curve, of one curve, and we would subtract out of it the area that's created with the other curve. I like to use the formula, the integration from a to b of the top curve minus the bottom curve dx. And when I say the top curve, I mean that curve that has higher y values for that region. Now eventually we're going to find that these regions can overlap, and we can have some where our top curve is f of x and our bottom curve is g of x, or our top curve could be g of x and our bottom curve be f of x. So in this case we would take the integration from a to b of that top curve, which is g of x in this case, minus that bottom curve, which is f of x dx. So let's go ahead and look at a couple of examples here. In example 1, I've got f of x equals x squared, g of x equals x to the third, and we're cutting it between x equals 0 and 1. I like to use this example because it has a very small region that we're creating. If we graph x squared, we have the graph that comes in something like this, a nice quadratic. Well, if I take a g of x, and we'll go ahead and label that as f of x as well. If I look at my g of x, my x to the third, I know that function is coming in, going through the origin, and it's going to go actually lower than f of x, but then come up higher. So we're going to see this very small region in there. And if we were to graph that equation on a normal graph, say if we, in our graphing calculator, we graph y equals x squared and y equals g of x, hopefully you can see that. Notice it doesn't look like we have much of an area in there at all. So what we would have to do is change our windows on this, and we're looking at a very small region. So let's say maybe -1 to 1, and our y min -1, y max as being 1. Now if I graph that, notice my x to the third coming in, and there's my x squared coming in. So now you can see this very small region if you look at that on your graphing calculator. So how do we find this area? Well, I know these 2 points of intersection. Well, the region that we're looking at is between 0 and 1. And I know by experience that we're going to go through 0. So if x equals 0, they're both equal. And if x equals 1, they're both equal. So I know my endpoints are going to be 0 to 1. My top curve is actually x squared minus my bottom curve, which is x to the third dx. I can go ahead and integrate that by hand. So I get x to the third over 3 minus x to the fourth over 4 from 0 to 1. Plugging in my 1, I end up with 1/3 minus 1/4 minus plugging in 0, we get 0. I know it's not required, and minus 0 means nothing, but you might want to keep putting something there just so you know that you've got to subtract off that a value. 1/3 minus 1/4, well, we have 4/12 minus 3/12, which gives us 1/12. Now in the calculator, we can do that as well, and we can find this integration. What are we going to do? Well, we've already got in our y equals, we have x to the third and we have x squared. So if we go back to our main screen, hit math, we're going to do a definite integration, so math 9. Our endpoints are 0 to 1. So our a value is 0, our b value is 1. we could type in x squared minus x to the third. Not difficult for us to do. However, more complicated functions get to be a little more cumbersome to put in. Since we already have them in y equals, if we come down here to vars and we go over to y vars and type in function, or hit number 1 for function, we can recall both of these functions. All I got to do is remember which function was which. If I go back to y equals, my y1 was x to the third. So I want y2 minus y1. So again, I'm going to go and quit. Coming back to my integration here, I'm going to do vars, y vars, number 1, number 2, so it gives me y2 minus, I'm going to go through that same process, vars, go to y vars, hit function, number 1. So now I've got y2 minus y1, or x squared minus x to the third. Type in my variable integration, dx, hit enter, and it gives me my decimal value. I can hit math, go to fraction, hit enter, and I get my answer of 1/12. The calculator is going to be very useful as we get into some very cumbersome and nasty looking problems. So let's look at example 2, where we have x to the third minus 6x squared, and g of x equals the x-axis. So again, we can go ahead and, in our calculator, type in x to the third minus our 6x squared. I'm going to go ahead and change my zoom back to a standard. And looking at this graph, we notice the graph comes up and then goes down and comes back up. And now I'm going with the x-axis. So if I come off to the side and look at what this graph actually looks like, maybe a little better, a little closer, I come up, coming down, and it's coming back up. I'm going through the point here 0 and 6. I'm looking at this area that's created with the x-axis. Now I'm creating an area, or I'm looking for the area created between these two functions. I'm going to have a positive area. In order to find a positive area, I have to take my top curve minus my bottom curve. Well, this is the equation y equals 0, so my top curve, or g of x, is 0. So I'm going to integrate from 0 to 6 of 0 minus my f of x, which is x to the third minus 6x squared dx. Now again, we have to be careful because we're multiplying that negative through. If you're going to make a mistake with these, you're probably not going to multiply that negative through to both of them, and you'll end up with an erroneous solution. Cleaning up this integration, we have 0 to 6 of negative x to the third plus 6x squared dx. Again, I can integrate this by hand. Negative 1/4 x to the fourth plus 2x to the third. If I increase that to 3, divide by 3, 6 divided by 3 gives me my 2. And I'm going from 0 to 6. So I have negative 1/4 of 6 to the fourth plus 2 times 6 to the third minus, plugging in 0 again, I get 0. I'm going to put that placeholder just so I don't lose it. And there's going to be my answer. Again, I can work this out if I want. Extended response, we can leave it. In our calculator, what does that look like? Well, again, we can go to our math, go to 9. We're integrating from 0 to 6. Here we can do 0 minus that function. Now I can go to my vars, my y vars, function number 1, and I have 0 minus y1. If we wanted to, we could take the negative of y1. That would give us the same thing, dx. And if I hit enter, I end up with 108. Now, a lot of you are going to say, is there a need to write all this if we can put it into the calculator? And as long as we have the calculator and it's a calculator question, it's not a problem. The problem is non-calculator questions. So you should be able to do that by hand. All right, our last example for this section, we're going to give you f of x equals x squared minus 4, and g of x equals the x-axis. So if I graph this, x squared minus 4 is going to go through negative 2 and 2, and it's going to go on the x-axis, and negative 4 here on the y-axis. So we're looking at this area created down here below the x-axis again. So we're going to integrate from negative 2 to 2 of that function below the x-axis, so we have 0 minus f of x dx is the way it's going to get set up. We could throw this in a calculator, or we could do this by hand. Doing this by hand, we could also, since we know that this is an even function, we could split this in half and integrate just from 0 to 2 of negative f of x dx. And by hand, that 0 allows us to do a little more math a little easier in our mind. So I'm going to go ahead and work it, we have 2 times 0 to 2 of negative x dx, because we have 2 regions that are equal since we're an even function. So if I integrate, I'll go ahead and write that integration out. We have 0 to 2 of negative x squared plus 4x dx. Remember, we're going to multiply that negative through. So looking at this, we have 2 times negative x to the third over 3 plus 4x, and we're going from 0 to 2. Plugging in my 2, I get negative 8 thirds plus 8. 4 times 2 gives me 8. Minus, when I plug in 0, notice I get that 0. If I would have kept it up here, I'd have had to plug that negative 2 in order to get that value. But now I can just multiply it by 2. So I have 2 times, well, I got negative 8 thirds plus 24 thirds. 24 minus 8 gives me 16 thirds. So it gives me 32 thirds. And that's going to give me the area of this region. Notice we have a positive area because we have the area between 2 functions. I think I had one more. I think I misspoke before. That's all right. So if f of x equals x plus 2 and g of x equals x squared minus 4, notice they don't give us a whole lot of information on this one. So as we graph it, and this will probably be a graphing calculator question, if I graph f of x, I can go through 2 on the y-axis. Nice linear function. Right, x squared minus 4 is going to look something like this as well. And we're going to create that region. So we're looking for the area of this region in here. Well, the problem is, where is that region? 2 ways we can go about doing this. We can set these 2 equations equal to each other by doing a substitution. Remember, these are both y equals. So we can say that x plus 2 equals x squared minus 4. Saying it equal to 0, we have x squared minus x minus 6. We can factor this, x minus 3, x plus 2. Setting both of those equal to 0, we know that x equals 3 and x equals negative 2. So we know this value is negative 2, and this value is going to be 3. In your calculator, if we go to our y equals, we can type this equation in, x plus 2. Our y2 is x squared minus 4. Again, if we graph that, we should see very similar to what we have by hand. And then we can find that point of intersection. To find that point of intersection, we hit calculate, second calc, our intersection, number 5. I like to move my cursor down to that first point that I'm looking for, hit enter 3 times, and it gives us negative 2, 0. We can do the same thing, second calc, number 5, move that cursor this time up to our other point, hit enter, 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 and it gives us our point of intersection. Hit enter too many times. There we go. So we see that we get the value of 3, 5. Y value is not of interest to us at this point. We're only looking at the x-axis because we're integrating with the variable of x. So again, we can set up our integration from negative 2 to 3. Our top curve would be x plus 2 minus our bottom curve, which is x squared minus 4 dx. go ahead and clean that up, the integrand. So we have negative 2 to 3. We have negative x squared plus x. We're going to multiply that negative through, so we get positive 4 plus 2 gives us 6 dx. Now we can go ahead and integrate negative x to the third over 3 plus x squared over 2 plus 6x from negative 2 to 3. Plug in your 3 value, plug in your negative 2. But again, if it's a calculator question, we're going to go in and go into Math 9. Clear the main screen there. Go into Math 9. We know those points of intersection, negative 2 to 3. So we're going to type in negative 2 to 3. Our top curve was x plus 2. It has higher y values in that case. So we're going to go to y1 minus y2. So our vars, y vars, function y1 minus our vars, y vars, function 2 dx. And we're hitting enter. And we get 20.833. Now the question is, what happens if you don't get the right top curve and the right bottom curve? What happens if we were to have taken y2 minus y1? Well, remember, if we take y2 minus y1, we're taking lower values minus the higher values. We're going to see, and I'll show you here, if we go to Math 9, from negative 2 to 3, now I'm going to do my y vars, y2 minus vars, y vars, number 1, dx. Notice I get just the negative value. So it's easy at this point to just take the positive value of that and call it a day. Be careful though, as we get more complicated problems later on, it won't always work that way.